Hi everyone, welcome back again to ASFC Chemistry, a synthetic route video for you now. I'd like you to pause the video in just a few moments, and what I'd like you to do is, considering there's one molecule in between these two, I'd like you to suggest a synthetic pathway in order to turn this cyclobutene into cyclobutanone. I need any reagents, conditions, mechanisms, anything you can think of that you think is appropriate for this, even a colour change if you know one, that would be great. So pause the video now and have a think, and then start the video again so you can see the answer. Okay everybody, welcome back again. Hopefully this is something along the lines of what you've got. What we need to do first is turn our alkene into an alcohol, and it is a secondary alcohol, as you can see I've labelled here. Because then this secondary alcohol is our only year one route to getting a ketone. That's the only way we know how to make a ketone. So rather than thinking, what can I do with this? What I hope you thought was, what can I make this from? Now, in order to get this alkene to become the alcohol, you use a reaction called a direct hydration. It involves a catalyst of dilute phosphoric acid. You need to use steam, which is why I've got the H2O gas, and a very high temperature and pressure for this reaction. What you also then need to do is, once you've got your secondary alcohol, which is called cyclobutanol, you need to make sure that you perform an oxidation. Now I've chosen to do a distillation for this, but because you're making a ketone, it doesn't really matter too much. The only advantage of a distillation is that the ketone actually has a lower boiling point than the alcohol, so as soon as it's produced it will evaporate, and then we can condense and collect it immediately using the correct distillation apparatus that, remember, you need to be aware of for the exam. Now what I use for that oxidation is an oxidizing agent, and here my oxidizing agent for year one is acidified potassium dichromate. When that reacts, it goes from orange to green, and it'll perform this oxidation for us under the said distillation conditions. Hopefully that clears up the synthetic route for you. If you have any other questions, then please let me know via the comments or send us a tweet at ASFC_chemistry. Until our next video, happy revising.